Welcome to the video lecture series. The unit number 1, electrical drives, fundamentals and dynamics. Okay, this is video number 2. Okay, in that video, we are going to see about the block diagram of the electrical drives and what is the method to choose the electrical drives, torque and the different types of the electric drives, etc. Before that one, we are going to start revise about that one. So what is a drive? Drive is nothing but a motion control. What is motion control? Motion control is nothing but a motor plus controller, or another name, motion plus speed mechanism. What is a speed mechanism or controller? There is generally two methods. One is conventional method, second one is solid state method. What is the difference conventional and solid state method? It's nothing but a electrical fan regulator and electronics fan regulator. Fine. Okay, what are the advantages of the electrical drives? It has the many advantages compared with the existing conventional engine method. Okay, it is a smooth, flexible, reliable, efficiency, etc. So that are the advantages. Okay, generally what are the types of the drives? DC drives, AC drives. How it is classified? Based on the motor. Either the DC motor means DC drives. If it is a motor is AC motor means AC drives. What is the difference between DC drives and AC drives? DC drives commutator is used. So due to that one is a frequent maintenance required. So and bulky due to that one. But it has a simple power circuit, power and control circuits. Okay. So like about it was classified. Okay, let's move to that today's sessions. Selection of the electrical drive systems. How do we going to select the electrical drive system? Based on your load, you can select the electrical drive system. Based on your load characteristics, you will going to select the electrical drive system. Okay, and further some more points. Source requirement. What is your source? Either your source is AC, then AC drive you can select, or if your source is a DC, then DC source is select. And how about the motor is reliable motor or not? You will going to check it about the reliability and space and weight. Okay, so you will going to check it about the space and weight. And what about the capital and running cost of this electrical drive systems? So what is the capital cost and running cost? You will going to look it. And how about it will going to work on the environmental locations, because AC motor is work most percentage of the environment locations, but a DC drives is not like that. Okay, then steady state operation conditions and transient operation conditions. Okay, these two. What is steady state operation condition? It include for speed torque characteristics. It's nothing but a mechanical characteristics. So we want to check about the mechanical characteristics. Okay, either the torque is directly proportional to N, or torque is inversely proportional to the N, or torque is directly proportional to the square of the N. I will repeat, either the torque is directly proportional to N, or torque is inversely proportional to the N, or torque is directly proportional to the square of the N. So like about the, we are going to see about the speed torque characteristics, speed regulation. How about the voltage regulations? Similarly, speed regulation, efficiency, duty cycle, quadrant of operation. So quadrant of operation, forward motoring, forward braking, reverse motoring, reverse braking. So these all the things is come under the steady state operation requirement. Then transient operation requirement. Transient operation, it is the acceleration of the motor, deceleration of the motor, starting, braking and reversing. So these are the included on the transient operation conditions. So these are the basic things we are going to check about that selection or choosing of the electrical drive systems. The next one is a block diagram of the electrical drive system. You can look at about this is a blocks mentioned about the general block diagram of the electrical drive system. Source. So what is the source of that? Our drive, either AC source or DC source, our motor. So if it is the AC motor, then AC source, or if it is a motor is a DC motor, then DC source. Otherwise no problem. Okay, with the availability of the motor, suppose here available motor is a DC motor, but available source is AC source, or AC source only available. Here is a DC motor. What to do? Then convert AC to the DC. That is a power modulator. Convert AC to DC. So how to converter? You can use the rectifier. You can use the rectifier. Suppose here is a DC motor. Okay, we were discussing DC motor. So it is any other possibilities? Yeah. Okay. Here is AC motor is there. Then here AC power supply, AC motor. Then AC voltage regulator you can use, or a cycloconverter you can use. Okay. Okay. Here is a AC motor, or you can use here is a DC source is there. Then DC source here AC motor. Then convert DC to AC. The name of the converter is called inverter. DC to AC is called inverter. So that type of the inverter power modulator you can use. Okay. Then the motor output is mechanical output, rotational output, or linear output. Okay, the linear. Okay, you can develop. Then motor. Okay, output is mechanical output is connected to the load. Load is working. Use the sensor. It will going to sense. So based on that one sensing, and you can give the command to the control unit with respect to our reference, or set the command compare and give the pulse to the power modulator. So this is about the basic block diagram of the electrical drive system. The power modulator is nothing but what are the elements? These are the 5 elements. 1, 2, electrical machines under load, then power modulator, sources, control unit, sensing unit. Particularly I am looking about the BLDC motor. BLDC motor, electrical vehicle they are using. How it is working? The inside of the motor itself, there is Hall effect sensor they will going to place. Hall effect sensor they will place. The Hall effect sensor command, output command, it will going to give to the controller. The controller giving the command, okay, through the power modulator to the BLDC motor. So where is the position of the rotor? That's like a BLDC motor is operated. Hall effect sensor, controller, power modulator. Hall effect sensor, another one is what is the controller, power modulator, motor. Okay, power modulator. So generally the power modulator is it's include what is the various of the converters. It's nothing but various of the converter. AC to DC rectifier, AC to AC is a voltage regulator or cycloconverter, chopper, DC to DC, DC to AC inverter, cycloconverter, AC to AC. Then variable impedance, power modulator. So add the variable resistance for controlling. Variable resistance for controlling. This is called variable impedance. Variable resistance for controlling, it's nothing but a electrical fan regulator. Conventional method. The next one possibility is switching circuit. Switching circuit. So switching circuit is used to, you will go to tune. So change the quadrant, and then change motor circuit parameter. Disconnect the motor in abnormal condition. Everything we will going to decide the switching circuits. You have look it. So here is a power supply plus minus. So it is a DC power supply. And here what is that one? You will going to give that one motor. Okay. Then it is a 4-quadrant operation model of the 4-quadrant. I mean chopper class E model it is given. So it is a 4-quadrant of operations. What is the 4-quadrant of operation? Forward motoring, forward braking, and then reverse motoring and reverse braking. So these all the things is performed with the help of the switching for S1, S2, S3 and S4. So these 4 switches is used to, you will going to achieve the 4-quadrant. Okay. The next one. So general connections. What is the general? So electrical motor, speed mechanism. Okay, speed control mechanism. So electrical motor, speed mechanism. It's nothing but a controller. Electrical motor and a controller. It's nothing but a drives. Electrical drive system. The electrical drive system is connected to the load. How do they connected? Motor is connected to the load. So here is a block diagram is simple mentions. Motor is connected to the load. It's not directly connected. Motor is connected through the shaft is connected, you are saying. Okay, through the shaft. Some more proper, that is called what is the some more. Okay, energy transmission device. For example, four-wheeler electrical vehicle, four-wheeler electrical vehicle, four-wheeler electrical vehicle. So motor is there, motor rotations, okay, and then backside of the wheel, okay, two wheel is there, that is rotations. Motor is a need to connect it to the backside of the two wheel. How to connect it? The term name is called a differential or gearbox. The differential gearbox or a chain, okay, like about the method or belt method or chain, okay, chain sprocket, like they will go to method. So out of these are the method. What are these are the method? Either the belt method or the chain method, okay, like about the two-wheeler chain method or tractor chain method or differential. So which one is more effective? Differential is more effective. So that is these are the mediator is called energy transmission device. Energy transmission device. This mediator is very important. The gearing arrangement, gearbox. The motor is connected to the wheel. How do you connect it? Are you connected directly? No. Are you connected directly? No. Then you will going to use the differential. Why do you want to connect the differential? If you are going to differential is a or gearbox method, differential method, or a chain sprocket method, the pulse value, the yeast value, if it is a proper, then you can utilize the energy output, full energy output of the motor. Utilize the full energy output of the motor. So that's why it is called a energy transmission device. Okay. So electrical drive systems, energy transmission devices, energy transmission device, mechanical load. So these are the combination is called the drive systems. What is a drive system means? These are the combinations. Okay. So I already told energy transmission device is nothing but what I can say about the gear, all the multi-stepped pulley method or belt arrangement method or differential method. Okay, like the soft is maybe permanently connected or temporarily connected. So gear method, okay, like you can use. Okay, then it is output. You have no. The output of the motor is called a rotational output. Rotational rotary motions output. Okay, rotary motion output. Or do you want linear motion output? Linear motion output. Yes, I needed linear motion output. Especially for four-wheeled electrical vehicle, I need it. So like you will going to use. So based on that one, you can select the differential. Then speed governors. What is that one? Speed controller. How do you control in olden method? Throttle. So throttle used to control the IC engine or jet valve in the case of the turbines. You will going to use. What about the electrical motor? You can use either conventional method or solid state speed control method. Conventional electrical method, for electrical machines laboratory, you are use the speed control of the motor. Armature control method, field control method, variable resistance is used, series with the armature, series with the field winding. So that is the conventional method. Solid state method means what? Solid state method means it is a power electronics controller. Power electronics converter plus controller. It is used fan regulator, electronics fan regulator method. Okay, is used to you can do. Okay. So electrical drive systems. What is electrical drive system? So electrical motor is used to drive the mechanical load. So electrical motor is act as the prime mover is called electrical drive motor. Okay, the electrical drive motor may be either AC power supply or AC motor or DC motor. So like a DC drives or AC drives, like it is classified. That's all.